Morning, everyone. Nice to meet you all. Okay, introduce myself. I'm David Inga. I am from the developer in Visuality. Also, my colleague and my friend here, Miguel Barrenechea. We both are front-end developers. Okay, a part of JavaScript, CSS, and React. We also work with web mapping and also doing visualizations. Maybe for 10 years. So we have some experience yet. So yeah, let's talk a bit about our company, because maybe you don't know about that. Yeah, it's a child-driven design and technology agency. In summary, we make digital tools and visualization for companies, organizations, NGOs that are aligned with biodiversity, conservation, and also with, we try to make the planet a bit better, hopefully. Okay. Okay. In this talk, what we would like is to show you why and how we use deck.gl. And also, my colleague Miguel will tell you two solutions that we have working with in our project. The first one, the code type raster, this is something that we already have implemented in some of our projects. Then the next animator raster style is something that we developed some weeks ago, so it's very fresh. But we will be implementing our projects in the next months. Okay, and also to finalize, we will talk about Sara Tanana. I'm pretty sure that it's about our own pronunciation, but it's in Madagascar. So we will see a visualization that we have and telling a history is something that we believe in it. Okay. So in Visuality, we mainly have two main types of data sets, vectors and rasters. Okay. With vectors, I think we really love vectors because it's very easy to work with. Also, we have several options. The speaker previously showed you some of examples that we can have. Well, it's very powerful. We are very lucky to have GeoJSONs because there we can store coordinates, points, lines, polygons, whatever, features, group. Also, we can add properties. We can have animation on the fly. We can have also interactivity. So it's very powerful. And also, in case of rasters, we can make vectors from these rasters, so we can have also polygons and use all the power that the vector provides to us. Just to tell you, with vectors in Visuality, we work with Mapbox, sometimes with MapLibre, also other platforms, but only a few cases. RGS, OpenLayer, something like this, but mainly Mapbox. And yeah, with these vectors, when we have heavy data, we have vector tiles, so it's something that is very powerful with Mapbox, And also, yeah, if we have more data, particles, points, or something like this, we are using deck.gl for that. But if you don't mind, I would like to talk more about the rasters, because this is a problem also we have, okay? And with the rasters, we have a few options, to be honest. Most of our solutions is to make a static tile server. So in the front end with the web mapping libraries, what we do is just to take the tile URL and show it in a map. But there are some other cases where these images have data stored inside every tile. So what we are doing is to storing in every pixel data. Okay, this is something that Miguel will tell you more in depth. The other problem that we have is in some of the cases we want animations. So something that we are experimenting is with satellite photo. And what we'll try is to, with the history, is to show you how we can make an animation or how we can improve the impact and also the visualization that we can do. And of course, it's based on deck.gl also. Okay, so Miguel.
So, yep. Thank you, David, for your introduction. Now we are going to focus on some raster layers. At the end, we are going to go for one layer that is called the code raster layer. The other one is the time series raster layer. After that, David will present you a use case where we can see both layers working together, and you can see the power of using both together. So yeah, let's start with the first one. We call it the code raster layer because it's just a simple raster tile layer where at the moment of creation, we are going to encode some data on each pixel. So at the moment of when we decode that pixel, we can set the color based on a formula. How we are going to encode this data inside of each pixel using the color bands. So as we are using images, yeah, we will have from 3 to 4 bands to set a number between 0 and 255. So yeah, we will have 3 to 4 colors because if we are using PNGs, yeah, we will use the channel alpha. Otherwise, we will have red, green, and blue. So for illustrating this, we are going to use an example. This layer, the tree cover loss, was developed by the University of Maryland, NASA, Google. The tree cover loss detects any change on the tree cover, defining tree cover as all vegetation greater than 5 meters height. And this change could be caused by many different things like human activities, forestry practices, timber harvesting, natural causes such as disease or storm damage, or fires is another kind of cause of this loss. So the frequency of this layer is annual. It has a resolution of 30 meters square. The maximum is 12, and the date of content goes from 2001 to 2021. So the thing here is the most important thing that you need to know is that we are going to store a loss alert at some moment of time between these 2 dates of content inside of each pixel. So if we take a look of one pixel of this layer, this is more or less one of the tiles. It's true that this is distorted, but because it should be a square. Let's start with the blue band. Yeah, we are going to store a number between 0 and 20, representing the moment of that alert happened in time. In the green band, in this case, we are not storing anything, but we could store maybe the cost as a number, so we could store a category there. And in the red band, we are storing the loss density. Why we are storing the loss density? Because as I mentioned before, this layer has only 13 zooms of level. So below that, we need to know, we are not going to show exactly where is the alert. We are going to show the concentration of alerts. So we will create like a shading. If you take a look to this image, the darker shading will represent high concentration of alerts, and the lighter shading will just the opposite. Will represent just the opposite. So if we compare some tiles between the zoom 13 and when you get the full resolution, here you will see that we are not applying any shading colors. So as a result, if we, as this is a tile layer, we will have like this will be the representation of the loss layer. Of course, when you zoom in, zoom out, you will be loading more tiles and they will be parsed. How are we parsing this? Or how are we creating the animations for animating this kind of layers? As we are using deck.gl, we are using the tile layer, we are using the bitmap layer, and right now we are using the extensions. So what we are doing is just passing a range of years as uniforms, and it will be as simple as showing or hiding the pixels that you want to show, because as those pixels have the information of the year, you will be able to do that. We have been working in this layer for many years. We started working in Canvas. We working in a Canvas, reading the image data and creating a really big loop through all the pixels of that image. So you can imagine that our maps were really poor performant. As soon as you try to move in, zoom in, zoom out, yeah, it was a pain in the ass. So then we moved to deck.gl, but was on a moment where we didn't have the tile layer and the bitmap layer yet. It was on an experimental state, so I imagine that it would be V6. But at the end, what we did was duplicate those layers and create our custom behavior. The good part was that at that moment we were using at least the parallel process of parsing or transforming all these pixels. And then the extensions came out, and this is for me one of the most powerful things from deck.gl, because it allows you to interact directly with the shaders, and it's quite nice because you can isolate and reuse all of them between different projects or different layers. The pros and cons of this layer is it has a good performance, because at the end you are only loading 16 tiles on average on a full width map, and there is no data size limit. So you can store, in this case, the loss layer, I think that we have like 3 million points, but as they are encoded in images, the problem will be for the guys that generate those images, not for at the moment of rendering. By the contrary, yeah, as I mentioned before, we only have numbers between 0 and 225 that are the colors that we can encode, and we have only 4 bands. So yeah, the limitations are there with the data we can encode. Of course, you need to know how the people encode the data inside the image. Otherwise, for you, there will be only colors. So you won't know that that was a year, or that was a category, or whatever. And yes, you can have access to additional data by picking, by hovering, by clicking on that layer. It's true that you can make a fetch to another endpoint, and you will find the data that you want. Yeah, about examples, we have a lot of layers using this technique. Not all of them are animated, but yeah, GladAtlas is a daily decode raster layer. Biomass density is not animated, but yeah, we can use this technique very widely. So now we are going to move to the next one. In this case, it was not about encoding data on the images. It was about changing those images through time. So we thought about many ways of doing this, loading multiple images, using videos. Remember that we are on a tile layer, so we are going to load as many videos as the viewport, as the tiles of the viewport. So we try different ways. So we are going to go one by one and check what went well and why we discarded some of them. So we started with them. Why not we load multiple images? Why not we try to, okay, for each tile, we will load all the information related to that tile. Yeah, if we imagine a full width map of 256 square tiles, at the end, we will be loading an average of 16 tiles, 14 more or less. So if we try to load, imagine 40 years of data, we will be loading at once, only per viewport, 640 images. So yeah, of course, this was discarded immediately. So we started to think, maybe what we need is to pack those images somehow. So why don't we use videos? The problem with videos is that there is no sync mechanism in the browser right now that allows perfect synchronization. So we try to use the current time, that is a property that has the video, to force that synchronization. But at the end, we end up having really bad performance issues. So we discard it, not at all, because at the end, if we compare all the sizes of the files, the videos is the best one if you want to compress the images. So maybe we will try to explore more this in the future, but right now it's discarded. So yeah, we thought, okay, maybe what we need to do, instead of loading 640 images, what we need to do is to pack those images and you can use APNG, GIF, and WebP. At the end, we are using a tile layer with a bitmap layer, and we are using the get tile data to get the image. So at this moment, we are parsing that image, extracting the frames, and returning, instead of only one image, we will return an array of images to the bitmap layer. Then with a simple variable, we can set which frame I want to see, but all the images will be loaded at once. Our best solution was APNG, and I want to tell you why. APNG supports alpha transparency, while GIF does not. It's true that GIF can support alpha transparency, but at the end you will have jagged edges. And okay, APNG supports 24-bit images, while GIF only supports 8-bit images. Yeah, the visualizations will be way better with APNG. APNG is lossless, while GIF is lossy. That means that APNG, you can compress APNGs and they won't lose quality, while doing that with GIF, it will happen the opposite. And of course, APNG is smaller than GIF. That was the main reason to go for APNG. If we compare APNG with WebP, all the attributes that I mentioned before are more or less the same, but by general, WebP is better optimized and it will be smaller. The only problem that we have with WebP right now in our site is that I didn't find a way of extracting the frames. So maybe if we explore this further in the future, we will find a way of extracting those frames to send back to the bitmap layer. The pros and cons, yeah, it has a really good animating performance because you are already loaded. You have already loaded all the images, and this is another pro, that you load, instead of 640 images, you will load 16 tiles that will have all the data that you want to show. But on the contrary, we need to be careful, because if you try to load, let's imagine 1 year of data, you will be loading 360 images in one APNG. So the size of those images could be really, 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 really big. So yeah, now David is going to present you the use case.
Yeah, thank you. Yeah, this is the last part. So I'm going to try to tell you, okay, I'm going to show you a visualization and tell you a history. Okay, so this is happening in Madagascar. Okay, this is an area. Let me open the browser and I can show you. Okay, it's there. Okay, this is an area in the north of Madagascar. There is a place called Saratanana, something like this. And yeah, as you can see here in this zone, we have some protected areas. Okay, primary forest. Primary forest is a forest that is not touched by the human. And also, you can see that happening something like free cover loss. This is the layer that Miguel was mentioning before. Is you can see in animation, this is the decode raster working with deck.gl, of course. And you can see what was the loss of the green areas. Okay, so as something that something that is happening here in this area is seems like there is some deforestation in this reserve, and it seems like it's due to fires, natural fires. Of course, it happens in the dry seasons, but also because the human impact. Okay, because you know, there are some interesting there. Relationship related with some crops like vanilla, rice, and also marijuana. Okay, so how we can see this? Because this is something that this is a project that we are working right now. So we think that okay, let's take this visualization and we can improve it if we can see. Why not? If we can see what is the result of the deforestation in this area. So something that we can do is something that this is what I'm going to show you is this is the area of Saratanana, okay? And this is the satellite base map, but this is the satellite base map in one specific year. But you can see here, this is a overlay, but this is a tile. We only generate for this demo a zone, okay, but we can complete the entire world, okay? And okay, and this is the area of Saratanana, and you can see, for example, when you click on the play, this is the time series raster layer working in combination with the loss layer. And we can use this visualization, for example, to contrast information, or maybe to see what is the effect in the zone with the satellite raster. And the performance, as Miguel was mentioned before, is really nice. You can see that this is the MPNG is working, and you can go to the frame direct, immediately. And also, you maybe in your transitions, you can add acceleration, maybe, and play with it. Okay. And the other thing, as I mentioned before, was you can construct information. You can see, okay, the Wi-Fi is a bit low, slow, but you can see, for example, how the loss layer is in the areas where we have this green or tree cover loss, right? Is the impact the same in this area. So, and as you can see the effect directly to this. And that's, and this is how we think we can improve this visualization. We can make more impact, and maybe, yeah, and this is also thank you to the deck.gl improvements. And this is what we are going to develop and implement in our projects. Okay. And that's all. Thank you.